Excellent.
Michael.
So hi everybody.
Like
Like I said,
Gemini.
my name's Andrew. I'm a member of the MIT Skydiving Club. So at MIT we study a lot, but we do like to have fun, and sometimes that's crazy kinds of fun, including skydiving. So I'm going to talk a little bit about the physics of skydiving for about 10 minutes, and then we actually have some skydiving equipment, including a parachute that we'll hold up and show how it works. And I've got a couple more members of the MIT Skydiving Club sitting in the back who will come up and answer some questions too. So, moving forward, I want to talk just a little bit about why you actually need to be smart to throw yourself out of an airplane, because it doesn't necessarily sound like a smart idea, and I'm sure the parents in the audience don't think it's smart at all for kids to be jumping out of an airplane, which it's not. You need to be 18, and you need to get a license to do it because it's pretty complicated. But there's a lot of physics involved in this, and we exploit it for our own amusement when we jump out of a plane. So really there are two major forces acting on you when you jump out of a plane. There's the force of gravity, which is pulling us down, and that's constant. The Earth is a certain size and has a certain amount of stuff in it, and that pulls us downward. There's also the force of drag, because as you get faster and faster, there's wind pushing back up. So the total force on a person falling through the sky in free fall is actually both of those together. So we write it in physics as a sum of those two, so gravity plus the drag force. So here's what it looks like in real life when people compete. There is competition skydiving, and they make formations, and they see how many they can make in a certain amount of time. This particular team is really, really good, and they can do 50 in 35 seconds. Wow. So they're all pushing against the wind to do these formations. You'll see their feet sticking out, their arms sticking out, they're doing some weird motions. That is all using the force of drag to reorient their bodies, to move up and down a little bit, to move forward and back so that they can make all of these different formations. So it's all about exploiting the forces that are working on you. So it looks like they're floating a little bit. They're actually falling towards the Earth. They're just really, really high up. At this point, they're going about 120 miles an hour, which is called terminal velocity, and I'll talk about that and how you get there. So the question is, how fast do you go? We get that a lot. It has to do with these two forces, gravity and drag. So if we write out the equations for it, this gravity has a couple parts to it. Really, it's the mass of the person or thing that's falling out of the sky. So I weigh about 150 pounds. That's my mass or my weight. And that gets acted on by the force of gravity, which is just relative to the thing that you're falling towards. So in this case, the Earth. If you skydived on the moon, you would go slower because there's less gravity. Then there's another part, and this one's more complicated, which is the drag, or the wind resistance from the wind in the air as you fall through it. So like when you go down the freeway in your car and stick your hand out the window, you feel a force pushing back on it. That's the exact same kind of force. And if you write down a simple form of the equation for it, it's got a shape component. So if I spread out into the wind, there's more force on me than if I tuck up into a ball. There's an area exposed to wind as well, so like a similar sort of thing. It's if I'm really spread out or if I'm really tucked up tightly. And then there's a velocity component, or speed. So the faster you go, the more wind is pushing back against you. So if you stick your hand out the car window going down the road at 5 miles an hour, there's a lot less force than if you're going 55 miles an hour. So that's a velocity component. That one's actually squared, so the speed really, really matters. So here's a break from the math and just more sweet videos of people jumping out of airplanes. So here you'll see them taking some different body positions that allow them to direct the forces so that they can actually fly forward a little bit or fly towards each other. So again, they're still falling here. They're probably going 150 miles an hour at this point. They're not wearing a suit. There's not a whole lot of area exposed to the wind. And they've got their arms back, so there's actually force pushing them this direction as well as back up and pulling them towards the ground. So like I said, there is a point where you can't go any faster. So it's called terminal velocity. You get there about 15 seconds into a skydive. When we skydive, we're in free fall for maybe 50 seconds before we open the parachute. We get up to about 120 miles an hour. And then you don't go any faster. You're still falling, you're still going really quickly, but you're not going any faster than 120. And that's because when you hit terminal velocity, the force pushing back up on you is the same as the force pushing back down on you. So there's the down part, which is negative, that's gravity pulling you towards the earth, and then there's the up part, that's positive, that's the wind pushing back against you. And at terminal velocity, these two have become the same. So when you add them together, there's an up and a positive part, and a down part, which is negative, and when you add the same number that's positive and negative, you get 0, and there's no total force. So you're moving at a quick speed, but there's no acceleration anymore. So here's a quick little graph of what it looks like when you jump out of a plane for the first 20 seconds or so. In blue is the velocity or the speed in miles an hour. It goes from 0 to negative 120. The negative, for us physicists, is meaning that it's pointing us downward. So you get up to about 120, and you'll see you don't get any faster than that after about 20 seconds. This is the acceleration plotted up here, so it gets towards 0 when you're at terminal velocity, you're not going any faster. So when you start off, you have gravity just pulling you down. Then the overall total force is just the gravity part and is pointing down. As we jump out, the drag starts kicking in and it goes up, and the total force disappears until there's none. And then you're not going 120 miles an hour and not going any faster. So I'll play that again, just watch the ball move along the line. So you're really speeding up, and now it slows down in terms of the rate of change, and you get stuck at 120 miles an hour because there's so much wind pushing back against you, you can't go any faster. Then, of course, at some point you want to open the parachute so that you don't hit the ground at 120 miles an hour. And what that does is it just adds extra drag. So that green arrow pointing up, you add a whole bunch more area above your head, and then there's a whole bunch more drag, and you slow down. So then it doesn't pull you upward, it just keeps you from going down as fast. So now you've got a bunch more drag, and then you do gravity, and you decelerate just by opening up more area. It'd be like spreading your body extra wide, except here, you're just doing it with fabric. And you do get a little added benefit from the fancy new parachutes because they do get some lift like an airplane wing, so you can actually control these things and fly them very precisely once they're opened up like that, and land wherever you want. And then, of course, people get fancy. You don't have to do it on your stomach. These people can go head first, feet first, any sorts of body positions like that are controllable. At this point, there's not as much area exposed to the wind. It's mainly just his head and his shoulders and maybe a bit of his legs. So he's probably going 200 miles an hour at this point because there's a lot less drag. He eventually stops going any faster, but when he gets to that point, it's a higher speed, so it's like 200 miles an hour for these sorts of people. And you can push against that wind once you've got it up there and flip over, move forward, move backward, all just by using these forces that you've got in the sky pushing back against you. So yeah, that's all I had in terms of presentation. Now we'll bring up actually a parachute and some equipment, and you guys can ask us some questions because we got about 5 or 10 more minutes. If you had questions about skydiving, want us to walk you through what a parachute looks like. One question we get a lot is, I'm wearing one of these jumpsuits. You don't have to be wearing a jumpsuit. It just gives us a more reliable thing for the wind to push against, and so it's easier to do formations, and I have a more reliable surface for everything to push against. Yeah, I'll point out how these guys work. So this is actually 2 parachutes in a container like this. There's a main one down here, that's what you would open up, and if anything goes wrong, which doesn't happen very often, but we want to be extra careful because we're plummeting towards the ground at 120 miles an hour, there's a backup one up here. So it's possible if the main one has something wrong with it, a little tear, it gets tangled, to get rid of the main parachute and go immediately to the backup. So there's a bunch of handles on this thing. To open the main one, you throw this one out into the wind. It's got a tiny parachute on it, it goes away from you, and then it opens up the big one as you saw in the videos. And then everything slows down because you've got a bunch of extra drag. If the main one has a problem, you can get rid of it with this handle, and then go to the backup one with that handle. Of course, you're going 120 miles an hour, so that's 1,000 feet in 5.5 seconds. So you want to be able to do that pretty quickly if anything's going wrong. We pull the parachute about 3,000 or 4,000 feet above the ground. So you have, maybe 20 seconds before you would hit the ground if you weren't to do anything about it. So these are really reliable, way safer than it seems now. There's a lot of technology in these. In addition now, they put computers in there that sense how high you are and how fast you're going. It's hidden up underneath his flap up there. So if you passed out or forgot to open the parachute for some reason, there's something seriously wrong, it would open it for you because it knows how fast you're going and it knows how high you are. So if you really had to, it'll just open it for you right before you hit the ground. So there's extra backups in these things too. But yeah, it's not very big. And then we of course learn to pack these and properly care for them, and then all the procedures for opening and closing them in the air. We practice a bunch of times, but that's really what one looks like. You don't see them too often. Does anybody have any questions? So once you open the parachute, it really depends on the size of the parachute and the flight characteristics of it. Maybe you're going towards the ground at 20 miles an hour or so. You can turn that lift, or the lift that you have from the parachute into a stall, so you can sort of pull it up right before you land, and the actual landing, you're not going very fast at all. It's more like stepping off a step or a table or something. So it sort of depends on how you're flying the parachute and how big it is. Yeah.
I've always wondered, since I was a kid, why don't they have parachutes on airplanes?
Yeah.
Let's just say the airplane's flying and it bent up.
Right.
When you reach a certain altitude, shouldn't they have those where people can just jump out, then release the pressure of the plane, and then everybody jump out safely?
Yep. Fortunately, airplanes are so well engineered that any situation where it would be useful to have a parachute almost never happens. Like there maybe has been one or two airplane incidents where a parachute would have helped. So I think that's really the reason it's just not worth it. And it does require, so it looks reasonably straightforward in the videos, but to even jump on your own, you need to do 25 skydives with instructors so that you learn how to stay stable and open the parachute correctly. So most people wouldn't know how to use them. I think it's part of it too. Yeah, right. Yeah.
Just to add a little something to that, there are actually a lot of instances of planes full of skydivers that have malfunctions, and the skydivers are wearing parachutes, but they're not able to get out of the plane just because it's spinning so fast. I mean, once the plane starts really having problems and it's going down, you can't even get out of it. So even these are inexperienced skydivers with hundreds or thousands of jumps, and they're already wearing parachutes, and they still aren't able to get out of the plane before it crashes. So there's a limit to how helpful it is.
Any other questions? Yeah. Yeah.
So can you jump out of any area in the United States, or is there any limitation for what place to fall?
Yeah, we're regulated just like airplanes are once we're under our parachute. So there's specific zones where you're clear to skydive. So we typically go up near the New Hampshire border. There's also a place in Orange, Massachusetts, where people go a lot. You do have to check in with the FAA to let them know they're going to be skydivers, mainly so the other airplanes don't fly through the space while you're flying your parachute, because they have engines and we don't. So they're going to win most of the time. Yeah. So you have to get it cleared. You can do it in the most different places, but like if they jump into a Red Sox game, they've done that ahead of time and everybody knows not to fly nearby. So, yeah.
How does the computer sense how high you are?
You want to take that one?
Sure. Yeah, so there's actually a little pressure sensor in there. So what happens is while you're on the ground at the start of your day, you turn it on and it calibrates to that ground pressure and says, okay, that is the ground level wherever you turned it on. And then as you're jumping, it senses the difference in the air pressure, and it uses that to calculate what altitude you are at above that ground level that you calibrated it. And then it just tracks how fast that changes to figure out how fast you're going down. And if you're going down too fast and you're at like 1,000 or 1,500 feet off the ground, then it fires a little explosive that actually bursts out your reserve parachute. So you kind of calibrate it on the ground level every day before you start jumping.
But yeah, it's all based on the fact that there's less air pressure up top than there is down here. And it's not a whole lot, but it's enough that we can sense it. So, and Banks here has actually built his own altimeter, because he's a mechanical engineer that does all that stuff. Any other questions that you want to talk about? Yeah.
What's the percentage of failures on these parachutes these days?
Yeah, that's a great question. So the numbers I hear are maybe your chances of having to use the backup are about 1 in 700. So and the chance that there's going to be something wrong with the main one is about 1 in 700 times. And then the backup parachute, we actually can't pack ourselves. It's packed by somebody whose job it is to pack backup parachutes. And it has to get repacked and inspected every 6 months. So the failure rate on those is even lower. There's no real good estimate because people don't use them very often. So it's maybe 1 in 3,000 or 4,000 times that would have a serious problem with it. Yeah.
What sort of pressures go through the body when the parachute opens?
What was that?
What sort of pressures go through the body when the parachute opens?
Yeah, so the parachute is actually designed to open somewhat slowly, which sounds counterintuitive, but it could be a big force, just opening and having that much drag all at once. So it opens in stages. It takes about 3 to 5 seconds for the parachute to open. And so it's sort of a pull on the harness that you're wearing, but it's really nothing substantial. People do it at all ages. There was just a 100-year-old skydiver recently. So it's designed so that it gets away from you and then sort of opens over a couple seconds. So that spreads it out over time. Yeah.
Is there any safety features you're planning to have like later on? Like if I'm trying to make this
There's been a lot of development lately in terms of ways to get rid of the main parachute and go to the backup. Like the main parachutes are really safe now, and part of it has been designing new cutaway mechanisms. What really made skydiving much safer was the ability to go from the possibly messed up main parachute to the reserve parachute, and there's these series of rings up here, which were developed in the 70s. Which sort of disconnects everything completely. So the main parachute is now completely away from you before you open up a good backup one. So that's been the big thing. There's also a little line here such that when you cut away the main parachute, it can help pull open the backup one. So you don't actually even have to use this other handle sometimes. So that's been the newest thing. Yeah.
So what height are you jumping down from? It starts at 38,000 feet, that commercial pool is 5.
No, the pilot requires oxygen above 14,000 feet, and so since we slide open a giant door and throw ourselves out the plane, there's not extra oxygen in that plane. So typically it's 14,000 feet, and then we open the parachute about 3,000 feet above the ground. But you can go higher if you have a supply of oxygen in the plane. It just starts getting really cold up that high. Yeah.
While you're skydiving, would you also need the oxygen as well?
So the requirements, I think, are you need to breathe oxygen in the plane if you're above 8, or if you're between 14 and 18,000 feet, and if you jump out above 18,000 feet, there's not really any breathable oxygen up there, so you need a bottle of oxygen to breathe. Yeah. Yeah.
What do you do with like the change in pressure, like in your ears, for example?
Yeah. So. You can breathe normally while skydiving, so for the most part, you clear out your ears yourself, and it doesn't require a whole lot of extra effort. Some people, if you have a clogged, like stuffy nose or something, it can be a problem. So I don't jump if I have a cold or like a stuffy nose, just because it's a pretty big pressure change. And so a lot of the same ways that scuba divers use to clear their ears, holding your nose and blowing a bit to pop the eardrums back out, people do that sort of stuff. Depending on how sensitive they are to it. Yeah.
Is it how you guys can foster your courage to jump from the plane?
That's actually my son's question.
Yeah, it's scary. The first few times it is really scary. And yeah, you want to take this?
Yeah. So. You have to see skydiving planes to understand, but I think we actually trust our parachutes more than the planes that we fly up in, just because these planes are flying up continuously all day, every day. It may not have the best, maintenance or all that. They've kind of got some duct tape in places and maybe some screws falling out because they know everyone's going to jump out of it beforehand anyway. So a lot of people trust their parachutes more than the planes they're jumping out of.
But at that high up, it really is more like floating than falling. And so you don't get that roller coaster feeling. So really, as long as you can mentally ignore what you're about to do at the door of the plane for a minute or two, then people do it. And I don't know why people seek this out. I mean, I've been almost 300 times. So after the first few, it's not so scary, but it definitely takes some sort of weird ignorance to do it the first few times. Yeah.
How much it costs for
Yeah. So parachutes aren't cheap. You don't want to buy the used one off Craigslist because they're kind of important. A parachute like this, maybe slightly used or in basic colors, probably cost $3,000 or $4,000. You can sell it back when you're done at about the same price. So it's an investment. A skydive for me costs $27 a jump, so that's not too bad. Going the first time attached to an instructor is maybe more like $200 because the instructor is very experienced and there's special equipment. So it's definitely not cheap. Sort of on par with maybe scuba diving. So maybe one more question if we have any. All right, well great, thank you guys again. Bug your parents about skydiving.